Let us discuss another question from strength of materials. You have a bar of length L which is hanging freely, and we need to find out its extension because of the weight. Okay, so you have a bar, and because of the weight, how much extension will be there? And the weight is given as W per unit weight per unit length. So it's weight per unit length. Okay, so that's okay. So what we do is, and A is the area of cross section. Now remember that in order to apply uh, Hooke's law, what does it say? Stress is equal to Young's modulus into strain, and for stress P by A, the load has to be there. Now, if you want to apply for the entire rod throughout in one go, if you want to apply Hooke's law, the load has to be constant throughout, and the area of cross section has to be constant. Here area of cross section is constant, but load is not constant, because let's say if the area of cross section here will not feel any load because there is nothing to support beneath it. Area of cross section somewhere in the middle will feel half of the weight as the load because it supports the bottom half, whereas the area of cross section at a point where it is hand will feel the entire weight because it supports the entire weight. Okay, so it all depends on the load is not same. So what we do is, that's why we take a small element here which is at a distance x from, x can be taken from bottom also, from top also we are taking from the bottom. So let's take a small element of length dx. Okay, and okay, so on this small element, what is the force acting on this small element? So on this small element there is a force acting which is Wx. Okay, and it supports Wx because the weight of this small element is less. So on the top side also there is a Wx force. So this Wx is the load P. So what is this Wx? Is the weight of this length x. So this Wx is basically the weight per unit length into the length. So weight per unit length is W into x. So that is the load acting at this point Wx, which is nothing but P. So this is nothing but P. So on this small differential element we apply Hooke's law. Hooke's law on that small element. So at that small element we'll first find out the strain. So at that small element the strain is the stress, which is P by A into P by A by stress by Young's modulus. So P is Wx, area of cross section is capital A, and E. So this is the strain at that point. Okay, and what is the change in the length? Let's say that is delta for that element. So strain is change in the length by original length. So at that point the element length is dx. Okay, and we need to find out how much is the change in the length of this dx. So that I am calling as delta Wx. So that is the strain. So strain let's say delta is the change in the length of the differential element by original length, which is dx. So this is Wx by Ae, and so dx, let's take that side. So Wx dx by Ae. So this is the, you can call as d delta also because it's the change in the length of that dx. So d delta. So this is for that small differential element. Now if we integrate, we get the total change in length for the total bar. So this you have to integrate because x is the variable, so 0 to L, and W A E is the constant. So integral x dx is x square by 2, and you are varying from 0 to L. So that is W L square by 2AE. So W L square by 2AE is the answer for this. Remember, this is a small easy problem, and let's look at the option WL square by 2A. This way is there in every standard textbook strength of materials, but this is the process. Okay, WL square by 2A. Answer is B. Thank you.